Hi everyone, my friends and I will be discussing on our assignment, which is question 13. Our group consists of 3 members and we are
Nur Ayuni Liana Binti Ahmad Pukhari. Student ID SA23004.
Mirza Husna Binti Razali and my student ID is SA23056.
And my name is Zul'Aleesya Binti Zulkarnain. My student ID is SA23010. Without wasting any time, let's proceed to the discussion. To answer question 13, first we need to look at mass spectrum. A mass spectrum here shows a peak at m/z equals 150, which is a molecular ion with the heaviest peak that corresponds to the intact molecule with a molecular weight of 150 grams per mole. This suggests the compound could have a molecular weight of 150, though the exact identity is not confirmed. The base peak, which is the tallest peak, is at m/z equals 135, and it is the most intense and indicates the loss of a methyl group, CH3, from a methoxy group, OCH3, a common fragmentation pattern for compounds containing methoxy groups. Additionally, a peak at m/z equals 77 represents a benzene ring fragment, C6H5, which is typical of aromatic compounds. Based on the molecular weight and the fragmentation pattern, one might hypothesize that the compound is 4-methoxyacetophenone, though other compounds with similar structure and mass could also be considered. To further confirm this assumption, we need to analyze further on FTR and NMR spectrum, and it would show the characteristic functional group absorptions such as the carbonyl stretch and the methoxy group vibration. Thus, it will help us to verify the presence of the specific functional groups and confirm the compound's identity.
Now, I will explain on how can we figure out about the structure that we want to find through IR spectrum. In this spectrum, firstly we need to analyze the key peaks, which is the one that is strong and distinctive. From here, which is in the range of 1200 to 1000 centimeters inverse, the methoxy group, which is OCH3, contributes a C single bond O stretching absorption. Next, let's see another strong peak in the range of 1700 centimeters inverse. At this range, we can figure out that there is carbonyl group in the structure where there is C double bond O stretching vibration happen. The last one is CH stretching of the aromatic ring appears around 3100 to 3000 centimeters inverse. To conclude this spectrum, we found out there are 3 different functional group in the structure, which is carbonyl group, aromatic ring, and methoxy group.
Next I will discuss on 1H NMR spectrum analysis. First, at 2.5 ppm it is a singlet, 3H. Where it assigned to the methyl group, CH3, attached to the carbonyl group. While for 3.9 ppm, it is a singlet, 3H, and it assigned to the methoxy group, OCH3, on the aromatic ring. Next, for 7.0 ppm, it is a doublet, 2H. Represents 2 aromatic protons in a symmetric environment, suggesting substitution on the aromatic ring. After that, at 8.0 ppm it is a doublet, 2H, that represents the other 2 aromatic protons, also indicating symmetry in the aromatic ring. The last one is 13C NMR analysis, where at carbonyl group, C equals O, it shows a distinct signal around 190 to 220 ppm, corresponding to carbon in a carbonyl environment. Next, the aromatic carbons appear as signals between 100 to 160 ppm, indicating carbons in the aromatic ring. Then, the methoxy and methyl carbons, where methoxy carbon, OCH3, resonates around 55 ppm, while the methyl carbon, CH3, resonates around 20 to 30 ppm, both in their respective chemical environments. From the mass spectrum analysis, the molecular formula is C9HO2, based on molecular mass and data. Where the double bond equivalent, DBE, can be calculated as DBE equals x plus 1, y/2 equals 9 plus 1, 10 halves, equals 5. This indicates the presence of 5 degrees of unsaturation, double bonds, rings, or aromaticity. Furthermore, for FTR spectrum analysis, the functional group of the spectrum confirms the presence of a carbonyl, C equals O, group, characteristic of esters. Therefore, for the proposed structure, that based on the NMR, mass, and FTR data, the compound is likely 4-methoxyacetophenone, containing a ketone group, COCH3, at position 1, and methoxy group, OCH3, at position 4 of the aromatic ring. Thus, this analysis aligns all spectroscopic data to identify the compound confidently. That's all from us, thank you.